Okay, so in other words, we're gonna go like this, we're gonna go 363 and 23, right?
Yeah.
And I hope most of you said one time, right?
Minus 20.
Minusing it, so we're gonna minus it, and we're gonna get 13, right? And 23 goes into 13.
Five.
Not 5 times. Oh, is it 5 times?
Yeah, it's 5 times.
Five times? Good, 5 times. I never be good card. And you get 108, and we'll get 18, right?
Yeah.
So we would have a remainder of 18 over 23. Right?
I remember.
Well, can't you put like point and then keep going?
Yeah, you can use some point and then
Did
keep
you have
going
the
like
zero?
direct remainder. No,
I don't
let's
remember.
add zeros on, right?
Yeah.
Okay. We're gonna do a little bit.
No, it's not.
That'd be the total opposite.
We're gonna, easy way to put it here, we're gonna divide polynomials. So, let's start with that one.
Okay, well, 2x goes in.
So we're gonna divide polynomials.
Oh,
2x minus 5. You see the elements complaining are the juniors?
Yeah.
I wasn't complaining. I
See, you
told
didn't have to put it.
Oh, I'm complaining.
Okay. So what we're gonna do here is this, and I kinda wanted to show through here. I'm gonna add a little bit to my problem. I got 6x cubed.
Yeah. He's gonna add.
There's no x's there, so I'm gonna put a 0x there.
You do that?
Yep. Because 0 times anything, it goes 0. Adding 0 to a problem is nothing wrong with that.
Okay.
So going through here now is I have this equation. Not gonna group them. This is kind of like factoring, but factoring out where it doesn't factor out nicely. And what we're gonna do is start, it's kind of just like we did before. How many times does this go into here, right? But we're just gonna look at the first term of each one of these. How many times, what would we have to multiply 2x by to get 6x cubed?
3.
3x squared. Because 3x squared times 2x is 6x cubed, right?
Okay.
Right, follow me?
Yeah.
Now what we're going to do here is go like this. We're going to take this, what we just put up here, 3x squared times 2x, we're going to get 6x cubed, right? Now we're going to take 3x squared times a negative 5,
Negative 15.
15x squared, and put it where it belongs underneath the x squares.
So it's kind of like foiling. Are you?
Kind of.
So you just forget about the 5 until that step.
Yep, forget about 5 and that step. Now this is the part that most people get confused on. You know, when we did that problem a second ago, we had the minus in front and we subtracted the numbers, right? When we subtract polynomials, we always have to run that through the parentheses, right?
Oh.
So people forget that
So how do
step.
you get the 15?
This?
Yeah.
3 times this, these two together.
So it'll be a negative.
3 times 5 is 15x squared.
Oh.
So you don't like anything. So as we go here, we're subtracting this, right?
Yeah.
So what I always say is when we do long division like this, instead of it's the same, we're subtracting, just change the signs. That's bringing that negative through the parentheses. We're going to change the signs. Now add them together. What's 6x cubed minus 6x cubed?
0.
0. And it better be 0, otherwise you did something wrong. Now the x squared. 15x squared minus 4x. 11x squared. Plus 0x. I'm going to bring the rest down. Like Carter said earlier, he said bring the stuff down, right? You keep bringing it down. Okay, now we're going to go to the next step. And this is a little harder one here. Boy, did I pick a nasty one to start with. 2x times what will give me 11x?
5.
5.
5.5.
5.5
X.
x. 5.5x. So we're going to go 5.5x. Not a
Will
nice
it
one.
always be plus on the top?
Oh, well, it depends if you're working with a negative. We'll see some different problems. We're going to practice a few here. 5.5x times 2.
Isn't it
2x times 2x is 11x
squared?
squared.
Minus
Minus, and now we have here is 5.5 times that, I believe, is 27.5x.
Oh. Wait, what did we do there?
Wait, what about the 7?
We took
This
that.
times this will give me 11x squared, right? This times this is 27.5x, right?
What do you do with the 7?
No, that's coming down. It's still there. Okay. Now we change the signs. 11x squared minus 11x squared is
0.
0. Gabe has that down to a T. 27.5 times x plus
7.
7.
2.
Now comes the hard part. 2x times what will give me 27.5x?
Schmidt, please come to the office. Emma Schmidt.
13.25.
No.
13.25. Okay. Carter's on the ball.
I got 7.5.
Is it 7.5?
I got 7.5.
Yeah,
It's actually 7.5.
Yeah.
Okay, Carter wasn't good. 13.75. Okay,
Oh, no.
not an x because we already have the x here, right? So 13.75 times 2.5x, right? A little harder. 13.25 times 5,
Is it 2.5%?
That's
27.5x minus 65, 66.25,
68.
68.25, 75, okay.
Equals 2.
Okay, 68.75, is that good?
Yeah.
Change the numbers, change the sign to me. I get 75.75, correct?
Yeah.
What's left over? You know, can I take 2x times anything to get this? Because this one doesn't have an x now, right? That's my remainder now, so this is your remainder. 75.75 over
Oh,
the whole problem.
2x.
Oh, that
can
is
we
our
just skip
problem.
this section?
Let's try another one of those on.
So, we're gonna try a few of them here, so,
Is
Yeah,
this
let's
what all we
try a
have in
lot
this
of them.
section?
pretty much.
I might
Can
be
we try a
able
lot
to-
of them?
Okay, try.
Not that one.
God, they get hard right
Yikes,
away.
push.
How about this? Let's just start with this one. X minus 3.
You hate the one. I would do square. Oh.
There. Let's try that one.
This might take us 2 days.
30 seconds.
No.
Shouldn't take that long. This is called long division. Yeah, long division. Remember that's the method's a lot easier.
Wait, whoa.
I'm lost already.
Yeah.
I thought I think I might have started already.
Okay.
No.
Oh.
Let's walk through it one more time, then I'm going to give you one by yourself. Everybody listen up quietly.
X.
Okay. Here's our first thing right here, right? Here's our first thing right here.
Yeah.
What times x will give me x to the fourth?
X cubed.
Okay, x to the cube. I made the numbers nice this time. X to the third times x is x to the fourth. X to the third times a negative 3 is a negative 3
X cubed.
x cubed. Now we're going to change the signs. That cancels off, so we're going to get 4x cubed plus 2x squared plus x minus 1.
Wait, that's supposed to be cubed up there?
Which one?
Up on top?
This?
Yeah.
Yep, that's
Oh,
cubed.
Yeah.
Everybody follow me?
Yes.
Now, how many times is x? What times x will give me 4x cubed?
4x squared.
4x squared. 4x squared times x is 4x cubed. 4x squared times a negative 3 is a negative 12x squared. Change the signs. Okay. What times x is 14x squared? 14x. So I got 14x squared minus 14x times a negative 3 is 42. 42x. Change the signs. 43x minus 1. Correct? Did I do everything right?
Yeah.
What times x will give me 43x?
43.
43, so 43 times x is 43x. 43 times a negative 3 is a negative 129. Change the signs. So our remainder is 128 over x minus 3.
Let's do another easy one like that one.
Okay, my question.
See, I get it.
There you go.
I did not know my own.
Okay, now I'm gonna give you a little, it's called the remainder theorem, I'll get into, we'll talk about more, this is a good problem to talk about the remainder theorem on real quick. The remainder theorem. Notice that what we divided by was x minus 3, right? Okay, everybody follow me?
Yes.
What makes that 0? 3, okay? Here's the remainder theorem. What makes it 0 is 3, right? If I plug in 3 into this equation, it'll equal 28.
What?
What's the point of learning
So
this
that's how we
then?
can check it?
That's a way to check it. It should be, that's a way, one way you know what your remainder theorem says this. If I take what I divided by, what makes it 0? Here is 3, right? And I plug it in for all the x's in this equation, whatever my remainder is what that value is.
So technically
why
that's
do
a
you
shortcut since I
So can't we just use that?
So that's a nice way, that's for just for remainder. What just happens to remainder? But I need to know the whole equation, okay? I mean, that's just a remainder theorem is only used for that. So it's like, if I say divide by 4, well, x minus 4, right? And then you divide it out and get the equation, and then the remainder. Well, if I say, what is f of 4? You could just do this division and get a remainder, and that's your answer.
Take 30 seconds.
Yeah, so, I mean, that's not too bad, right? Okay, that's the remainder theorem, right? Okay, we'll come back to that. How about this one? How about x minus 4 into negative 3x to the 4th plus 2x cubed plus 3x squared minus x minus 7.
I can. Did you just like make it to the top of your head?
Let's do bottom sheet down there. So what? Let's do it, start right here, we'll extend the page. Remember synthetic?
Oh, synthetic? No, I thought this was synthetic.
No, this is long. Okay, we'll come back to
Yeah,
synthetic.
I don't know.
Anybody remember synthetic?
I bet I can figure it out.
Without looking your book? Okay, we'll do synthetic in a minute.
I got this. I got this.
I'll do synthetic.
Oh, I know how to
I
do
don't
it.
remember how to start it.
I know how to do it, coach.
I looked in my book.
What?
I can't breathe.
She looks beautiful.
That's not what I asked.
Get that problem down, long division.
You don't learn until.
Okay.
How do you
Oh, I get it.
how
Is
do
there any
you
way
know
for these to be
how
like no
this-
solution?
This goes into there.
There's no solution, okay? Well, let's think about it. What times x is going to give me a negative 3x to the 4th?
Negative 3 third.
Okay, negative 3x to the 3rd.
Oh, okay, get it.
Negative
What?
3x to
Oh,
the
wait,
3rd.
no.
Okay? Right?
Oh,
So now I got negative 3x to the 3rd times x is a negative 3x to the 4th. Negative 3x to the 3rd times negative 4 is
It's negative 12.
plus 2 negative to positive.
Yeah, so 12.
X to the 3rd, right?
Yeah.
But now you have to change the signs.
Yeah.
So I'm going to get a negative 10 x to the 3rd plus 3 x squared minus x minus 7. Okay? It's a little nasty, doesn't it? What times x will give me negative 10x cubed? Negative 10x squared, okay? Negative 10x squared. So negative 10x squared times x is negative 10x to the 3rd.
Okay, so
Negative 10x squared times a negative 4. 2 negatives make up 40x squared. Change the signs. That cancels off. We get a negative 37x squared minus x minus 7.
okay.
Good? Remember? Are we okay? Carter's, you got, this isn't too
I
bad.
did 4,
I can't stand it.
X times a negative 37x. What times x gives you negative 37x squared? Negative 37x, okay?
He had everything right, he did my math wrong.
Negative 37x squared. Now we're gonna get some bigger numbers here. Plus 148x. Change the signs. We're gonna get negative 149x minus 7. Is that right?
Oh my god. See, I
Check it.
Okay. Then what times x will give me a negative 149? Negative 149. So we got negative 149x plus, and I have no clue what the number is. 464.96?
596.
596. Change the signs, and I get a negative 603. So my remainder is a negative 603 over x minus 4.
I should have known that.
I get it.
I
So
get it
now-
already. Just
Let's think about the remainder theorem real quick here, just on this problem too. What makes it 0?
4.
4. If I plug in 4 in for all my x's, what will I get for a remainder?
Negative 603.
Not a remainder, what would I get for answer? The negative 603, right? So that's kind of that remainder theorem. Okay? One more. One more. How about this?
Oh,
I like that.
This is the only part
I'm
here is
gonna
the
do
ring
the
theorem,
synthetic.
dividing it.
Was that?
Well,
All the section is on it, just dividing it.
Divided. We're gonna do it another way here in a second. Okay, x cubed. Okay, do that one.
I know how to do synthetic.
It's nice and synthetic. Synthetic only works when you know what makes it 0. Like when you had x squared on the outside as well.
Synthetic theorem's key.
Okay, can I go through this one yet or not yet?
Yeah.
Okay, what times x give me x cubed?
X squared.
X squared, so x squared times x is x cubed. X squared times a negative 2 is, change the signs. Then negative x squared plus x minus 2, right? What times x will give me a negative x squared?
X. Negative X.
Negative x. Negative x squared plus 2x. Change the signs, so we're going to get a negative x minus 2, correct?
Negative X.
What times x will give me a negative x? Negative 1. So we got negative x plus 2, right? Change the signs. Negative 4. So we got a remainder. Negative 4 over x minus 2, right? So if I plug in, what makes it 0?
2.
If I plug in 2 for all my x's, I'm going to get an answer of negative 4. Okay, now I got a couple questions for you. We're going to do 2 more things here. First question is this. If I plugged in, if my remainder was 0, and I have no remainder, what would that tell me?
That it wasn't.
There's no
It wouldn't
remainder.
work when you
There's no,
plugged it in.
there's no remainder, but.
You plugged in 0, it'd be
Function.
2. It'd just be
Okay.
your last number that didn't have any.
If there's no remainder, that tells me it's a 0. That means it would square crosses the x-axis.
At 0.
No, it just, so if I plug in here, let's say I plugged in here this equation, and I plugged in two and I came up with no remainder.
Yep.
That tells me this equation
Crosses the x-axis.
at 2.
Oh, okay.
That's it, it's 0. It's a 0 of the equation. Okay? There's no remainder. That's important to know because we're going to use all these techniques in a little bit. If we take a number and do this out, and it comes out remainder of 0, that means it's a 0, or it crosses the x-axis there, right? That means it's a factor. That means if I was factoring out this equation underneath that bracket there, if I was factoring it out, one of the factors would be x minus 2 because it comes out even. That means if it's a remainder of 0, it comes out even. Okay? Now I want to do something different on this problem. I want you to do this for me. What makes this 0? 2. Okay? What I want you to do is put a 2 up front and put a little box like that around it. Okay? Now I want you to just look at this underneath here and go like this. What's my first number? Just numbers. 1, next one. -3, next one. 1 and -2, okay. Then put a line down here. And this next step is going to be real hard. What I want to do here is this. First thing I want you to do is the first number past this bracket, bring it down.
1.
1, okay, bring it down. Okay? Everyone follow me so far? 2 times this. 2. Put it here, add them together. -1. -1. Got it?
Wait, what?
So I just took 2 times 1 is,
Where'd you get the 1 more?
I just brought it down.
Oh, you brought it
So 2 times, now I brought it up here, add them together, got -1, right? 2 times a -1. -2, add them together. -1. Okay? 2 times a -2. 2 times a -1.
-2.
-2, add them together.
-4.
Okay, everyone follow me? Okay, now we started with x to the third. Go one level lower. X to the 1x squared minus x minus 1, remainder of -4.
What?
So much easier.
What?
So now look at your answer. Are they the same answers? Same answers. That's called synthetic.
How would you use that?
So that's synthetic division. The only reason I don't use synthetic all the time is because not all the time we can figure out what makes it 0 in the front. If I was using x squared minus x plus 1, there's 2 answers. You can't do synthetic. If you can do, like for example, if I said this problem here, and I asked you to go x minus 5 into x to the 4th plus 3x squared plus 1. Okay? So what makes it 0? 5. Now you have to be careful here. You got x to the 4th. Let's read the numbers off. 1,
3.
0,
Oh.
3,
Wait, how's that 0?
0. No x cubes. We still have to put them in there. So if there's no variable between them, you still have to put a 0 in.
I see.
So now if I was working this problem out very easily, to do synthetic division on here, we started with x to the 3rd, right? Or 5th? 4th. X to the 4th. Break down the 1. 5 times 1 is?
5.
5. 5 times 5 is? 28. 140. 140. And 720. Which is 721. Okay? Synthetic division, very easy, right? Just brought the numbers, multiply by the next one, right? Now I started with x to the 4th. Now I'm down to x to the 3rd. So this would be 1x third plus 5x the second plus 28x plus 140. Remainder 721 over, what was it, x minus 5?
So you just keep timesing by that number?
Yep, just times this number.
Wait a minute.
140 times 5 is 700.
Well, then how come
140
we
times
did
5 is
the-
what?
700.
Yeah,
It's
wait.
700?
The first one, shouldn't the first one be 5?
Yeah.
Can you just bring that number straight down?
Bring that number straight down. 5, then? 7.
Wait, no.
It is.
Oh yeah, it is 700, my fault. 700. Plus 701?
Mhm.
I can't multiply. 701.
And how come we used it like an x cubed?
Is it?
Like we plugged in an x cubed up there, but this there's just never gonna be.
What do you mean plug it? Like here's x to the 4th,
Yeah, now it's x cubed, and then now it's
x cubed, now it's x to the 3rd. It's always one level lower. I think it goes one level lower. So I always say level, because we start with x fourth, now we know the x cubed, right? Now here's a tough question. What number can I plug in for my x's? 5. That's remainder, right?
Yeah.
Yeah.
If I plug in 5 in for my
So
x's,
you get 701.
I should get out 701. Now, when you think about that now, you said earlier, why can't we use this long division, right? Now, I can see using that for plugging in values. If I went and plugged in 5 in that original equation, that'd take me a little while to do the cubes and the squares and all that kind of stuff, right? Doesn't take long to throw this together. Really, if I just wanted to know the value, it doesn't matter about the equation part, right?
Can you show it to me one more time?
So, let's try another one of these. Let's see what I have. Oh, this one.
No, we just, oh.
Same thing.
Everybody's
Everybody's pretty good. It's different.
do it the easy one.
Whatever way you want to do it. Actually, do it both ways.
I just did.
Do it both ways. Check if you get the same answer. No, that just blows my mind when I tell you to do it both ways, and people do it both ways and get different answers. They say they're still right. So, do people have iPads in here?
I have one of my desk.
Okay. I'm just seeing here that 2, and I'll get my. Oh, actually, I'm missing 3. 1, 2. Anybody else? Here, there's 3. I'll get my butt 2. Like I said, that's a nice easy way. If you do long division first, I'll work it out. This would be 3x squared minus 12x squared. This would be 7x. And plus 35. Agree? No, if I would do it at long division,
Wait.
did you do it both ways?
My second way works when I first read it. I have both. I got them.
I got both.
Also,
3, 12, 7, 28,
I got a 35.
35, 140,
Mm-hmm.
132.
Oh, it's minus 8.
Agree? Yeah, this way's a lot faster, but it's a nice way to check your answers too, you know? The reason I say check your answers is now, when I say everybody's gonna do a synthetic division, right, because it's easier. You know, like I say, you can do synthetic when you know the value in front right away. If I went back to a problem here, like this one,
Synthetic.
you can't do synthetic, you can't do bonds.
What meaning?
You can't say what makes that thing in front zero. Okay. Now, we get a little more advanced here. This is the start of them. And we're going to do, could be do synthetic division. Imaginary numbers. Yeah. So we're going to do some synthetic with imaginary numbers. So we want to do some different ones here. We're running out of time right now here today, so we got synthetic down, and I've already talked about the remainder theorem a little bit here. Factor theorem, we will talk a little bit tomorrow. That leads into the next section anyhow. So on your, you can start looking at it in your packets. Let me get it right up here real quick. So we are on section 3.3. We got a long section. Then we got 3.4, and then we're done. Okay. Let me get this up here real quick here. 335. Break out. Hang on. No. Is that the right section?
Yeah.
Monday's a test. So there won't be no midweek or daily week quiz probably. 335, 3 through 57 by 3s. Oh, I don't know. Which looks like a good one.
Every third one.
19. Wait, I have it.
Every third.
21.
Yeah, but every third is two.
Oh, so like the green. So if you go by sixes.
If you're only doing the stuff they want to do.
Well, yeah.
Many would be going to 6.
No, what would it be?
45 and 54. I meant to throw a word problem on
Did you learn how to do
here. Yeah, this is read. A couple of things about this now. No synthetic. Yes, it's nice. I'm going to repeat this. But also no long. Now we're going to lead into long division. Synthetic we're going to use a lot in the next section. The section after that, after we get the mid-check test, we're going to use a lot on long division. Okay, now what happens in long division, how we use it is this, okay? Does everybody know what an isotope is?
We're talking about it.
Imaginary line that the graph gets close to, right?
Yeah.
We kind of dealt with a couple of them already. We've dealt with the vertical isotopes, right? We've dealt with a little bit of the horizontal isotopes. This is going to lead into dealing with slant isotopes. So it's not vertical, horizontal. That's what we need this for. The long division is needed for slant, so we have to know this stuff. Okay?
Yeah.